Alright, this is our last test as far as a review for the midterm. So let's get started. Number 1, it says find the sum of the measures of the interior angles of a polygon with 11 sides. The sum of the measures of the interior angles. It means all the interior angles, all the inside angles, what do they add up to be? Not each one, but what do they add up to be? Thus the word sum. Alright, make sure we understand that. So we have a little rule for that. Number 1. So it's n minus 2 times 180. That's how you find the sum of the measures of the interior angles of a polygon. N minus 2. N meaning what? How many sides does your polygon have? Well, we have 11 sides right here. So it's 11 minus 2. I know you can do that in your head, but we'll do that anyway. So it's 11 minus 2 times 180. Of course, that's 9 times 180. And you punch that into your calculator. Let's see. 9 times 180. I'm doing it right now. 1620. So 1,620 degrees. That's the sum of the angles. That's the sum of the measures of the angles inside a polygon with 11 sides. All right. Number 2, it says find the measure of an interior angle of a regular polygon. Now that's a little different. Regular polygon means all the angles and all the sides are equal to each other. In this case, we're more concerned about the angles. So all the angles are equal to each other. So it says find the measure of an interior angle of a regular polygon. I'm sorry, it doesn't say find. It says the measure of an interior angle of a regular polygon is 144 degrees. What's the number of sides? So each angle measures 144 degrees. We want to find out how many sides does this polygon have? What kind of a polygon is it? Alright, so let's see, the measure of an interior angle is 144. You know, the best way to do this is to think to the exterior angle. I know it says interior, but if the interior angle is 144, then the exterior, if you remember the relationship between the exterior and interior angles, they're supplements of each other. So if I go 180 minus 144, that's a 6 and that's a 3. So each exterior angle is 36 degrees. Well, that's not what they're asking for. So why in the world am I going in this direction? Well, I'm going in this direction because I know that the sum of the angles of any polygon, the sum of the exterior angles, I should say, of any polygon is 360 degrees. So if I took 360 degrees, which all the angles add up to be, all the exterior angles add up to be 360 degrees, and I know if each one is 36, then I take the sum of all the angles divided by each angle. That will tell me how many angles I actually have. So 360 divided by 36, I don't need a calculator for this one, and that would be 10. That means you have 10 angles, 10 exterior angles. Well, if you have 10 exterior angles, that means we have 10 interior angles, which also means we have 10 sides. So that's how many sides we have, and that's what they're asking for right there. So what did I do? I found the exterior angle by subtracting from 180, then took 360, which is the sum of the exteriors, divided by one of the exteriors right here, which is 36, and you get 10. That's how many angles you have, therefore you have the same number of sides, so 10 sides. Okay, let's do number 3. Says the measures of each interior angle. It says find the measure of each interior angle of a regular polygon with 16 sides. Well, we can kind of go through this thing right here, but we're not just finding the sum, we're finding each interior angle. Again, it's a regular polygon, so all the angles are equal to each other. So I start off like this, n minus 2 times 180, so that would be 16 minus 2 times 180. Now what I'm going to do is I'm going to take that. That gives me the sum of all the angles. Now remember, it's a regular polygon, so all the angles are exactly the same. So what I can do is I can divide. That gives me what all the angles add up to be. And then I can take that number, it's a big number, 14 times 180, whatever it is. Then I take that number, I divide it by 16. I divide it by 16 because I take the sum of all the angles, divide it by 16 angles, and that'll tell me what each angle is. So I can just chuck that in my calculator. So what do I got? 16 minus 2 is 14 times 180. That's a big number. It's 2520. Divide that by 16, and then I get 157.5. So it's 157.5 degrees. That's what each angle in this polygon is. So if I have a polygon with 16 sides, not just any polygon, a regular polygon, which means all the angles and sides are equal to each other. So if I have a regular polygon with 16 sides, each angle inside, each interior angle inside that polygon is going to be 157.5 degrees. Alright, let's take a look at number 4. Here's a picture I made a little bit bigger so you can see it, because that's pretty tough to see. And it says just solve for x. Alright, well, we've got a quadrilateral. Now we don't know that this is a, well actually we do, because these two are equal and these two are equal. So, let's see. Yeah, we could say, sure, trying to think of the best way to do this. Yeah, look, both pairs of opposite angles are equal to each other. Right? If both pairs of opposite angles are equal to each other, we know this thing is a parallelogram. Well, what's another thing? You could do it two ways. This is why I wasn't sure what I was saying at the beginning. You could take all four of these, add them up, set them equal to 360, because they all add up to 360. Or you could do this. Since you know it's a parallelogram, you could just take these two consecutive angles and you can add them up and set them equal to 180. It might be easier to do it that way. Sorry for the confusion. But on a lot of these problems, there's more than just one way to do this. So I would do it like this. I would just add these two up, set them equal to 180. And now you just solve for x, no big deal. 6x and 2x, that would be 4, and that would be 176. And I should know this, but 176 divided by 8 is 22. So x is 22. And that's all they ask you to do on this one, is to find x. Okay, they don't ask you to find the actual angles. They could, or I could ask you to find each of those angles, but they don't. They just say solve for x, so you're good with that. All right, let's go on to number 5. All right, and this one says find the value of each variable. So there could be more than just one variable, and there is. There's a and there's b. But it doesn't just say find the variable, it tells you that it's a parallelogram. Okay, and it's important that they tell you that it's a parallelogram. Nothing in this picture tells you that it's a parallelogram. And you say, well, it looks like one, but you can't just go by the looks. So they do tell you it's a parallelogram. What do we know about the sides of a parallelogram? Well, we know that the sides of a parallelogram are congruent, or equal to each other, the opposite sides. So these two are equal, these two are equal, so that's pretty simple. The geometry is easy, you just have to figure out how to set it up. Once you know how to set it up, then it's pretty easy to solve for a. Subtract a from both sides, add a 4, divide by 2. And that's what a is. But you also have to find b. You got to get both of these to get this problem. The opposite sides are equal, so these two are equal to each other. Right, it's no more difficult, so 2b equals b plus 1. Subtract b from both sides, you get, oops, it's not negative, b equals 1. So there's your answer. You get 3 for A and 1 for B. Okay, number 6, we're solving for x and y. Look, I wouldn't, you could do this. Now, this is parallelogram again. Now, the consecutive angles right here are supplementary. So you could add these up, set them equal to 180, but the problem with that is you have x and you have y. The best way to do this is actually solve for y first, because they're opposite angles. That's the easiest way to do this. So if the opposite angles are equal to each other, just set them equal, and then we'll solve for y. Don't think you always have to solve for x first. Sometimes you solve for y first. Alright, so you just set these equal to each other. Why? Because opposite angles of a parallelogram are equal to each other. Subtract a y from both sides, add a 40, and you get 50. Alright, just like that. And now you got to solve for x. So now we can look at these and say that they are supplementary to each other. But since we know what y is now we know what this angle is. So that's 50 plus 10, and that would be 60 degrees. So you know this one plus this one equals 180. So 4x plus 60 is 180. So 4x equals, subtract 60, which is 120, and divide by 4, and x is 30. There it is. X is 30, y is 50. Alright, this is number 7. Write it down there. Now we have diagonals. Well, what do you know about the diagonals of a parallelogram? Well, you should know that they bisect each other. That means that this segment and this segment are equal to each other, and these two are equal to each other as well. So it's just a matter, again, of setting these things equal to each other. So I've got 4x equals x plus 6, subtract an x, 3x equals 6, x equals 2. Then you do the y's. Same thing, you just set them equal to each other. 5y minus 8 equals 3y plus 1. Subtract a 3y from both sides, you get 2y. Add an 8 to both sides, you get 19. Alright, and that's a little... hang on just a second, did I do that right? Oh, why did I put 11? I knew I did something wrong here. I guess I saw those two marks right there. I thought it was an 11, but that's actually a 1. So, if I add an 8 to this, I get a 9. That's a little bit better. Divide by 2, and there you go. Y equals 9 over 2. You can just keep it like that. You don't have to change it to a decimal. I'm fine with that. Alright, the next two are real simple. There's really no math involved at all. It's just understanding some stuff. Wonder why that didn't. There should be a little tick mark here and a little tick mark here. I don't know why it didn't when I copied and pasted, but that's okay. Here we go. We have to determine whether it's a parallelogram or not. Well, look. A lot of people when they took the test the first time said yes, this was a parallelogram, but it's not. We don't know enough information about this to say that it's a parallelogram because we don't have a theorem that says one pair of parallel sides are parallel and the other pair are congruent to each other. We do have, so this is no. All right, that would be no right there. But if, let's say you know that this side and this side were equal to each other and parallel, all right, so we're doing a what if here. What if we had this? If we had this situation, if you have one pair of opposite sides that are both parallel and congruent to each other, then yes, you could say that this is a parallelogram. But that's not what we had, is it? We had just these two sides being equal and the other two sides being parallel. That's not enough information, so the answer would be no here. Let's look at this one. Let's look at the opposite angles. That's what they give us. These two opposite angles are equal to each other, and these two opposite angles, are equal to each other. So that means that this must be a parallelogram, because if opposite angles are congruent, then it's a parallelogram. All right. You could also do this. You could say that the consecutive interior angles are supplementary. If the consecutive interior angles are supplementary, then it's a parallelogram as well. So a couple ways that you could look at this and decide if it's a parallelogram. So no work, you just have to understand the rules for parallelograms. All right, 10 through 13 is the same picture, so I'll keep this picture up here and then we'll work with each one individually. It says RZ is 3x plus 8, and let's just do that. RZ, 3x plus 8, so that goes right here. This is exactly what I would do if I was taking this test. ZS is 6x minus 28. 6x minus 28. And we are trying to find UZ. We'll just call it x, if that's it. Let's not call it x. Let's just call it, I don't know, we'll just call it UZ. We'll put a little tick mark here just to remember which one we're trying to find. All right. So it says this is a rectangle. All right, so this whole thing right here is a rectangle. Well, what do we know about a rectangle? Well, we know we have all four right angles. That really doesn't help us too much with the sides, but what do we know about the diagonals of a rectangle? Well, on a parallelogram, let's go back. On a parallelogram, we know the diagonals bisect each other, but specific to a rectangle, the diagonals don't only bisect each other. Now they do, but they don't. That's not the only thing they do, but they're also equal to each other. So RT and SU are equal to each other. So what do we say? Parallelogram, they bisect each other. On a rectangle, they're congruent to each other. So watch. If this RT and SU are equal to each other and they bisect each other, guess what's true about all four of these? All four of those are equal to each other. So if I can find x, I can plug it in, find one of these. Any of these four are going to be exactly the same. So what I'm going to do is I'm going to solve for x. Remember, this and this are equal to each other, so I can very easily go 6x minus 28 equals 3x plus 8. I can solve for x. That's not my answer, though, is it? I got to plug it back into either this one or this one. It shouldn't make any difference because they're both equal to each other. So let's solve for x. Subtract 3x from both sides, and I get 3x. Let's add a 28 to both sides, and what will that give you? 36. Divide by 3, x is 12. Now, that's not my answer. I have to find what either RZ is or ZS is, because that's going to be the same thing as UZ. Which one would be easiest? Probably this one, wouldn't it? So let's plug in 12 for that. So 3 times 12 plus 8. So 3 times 12 is 36. Okay, plus 8. That would be what? 46? Or I mean 44. Sorry. That'd be 44. And that's what UZ would be right there. So UZ would be 44. Alright, let's keep going. Let's do number 11. So let's see. Let me see it in front of me. It's easier to read the paper in front of me. RT is 5x plus 8. So RT, that's that whole thing. So I'm going to do this. That whole thing right there is 5x plus 8. Try not to make it too messy here. Alright, and RZ is 4x plus 1. So just from here to here is 4x plus 1. It says solve for ZT. So I'm solving for this. Again, I'll put a little tick mark there just to show me that's what I'm going to solve for. Alright, well, what do they tell me? They tell me the whole thing, and they tell me this. Remember, it's half of it because it's bisected. And I want to find this. So really, all I got to do is find RZ. If I can find RZ, ZT is the exact same thing, and then I'm done. So we got to set up some kind of relationship. Now look, RT is RZ and ZT together, right? Added up. So RT is actually twice as big as RZ. Let's write that. RT, which is 5x plus 8, is equal to twice RZ, which is 4x plus 1. Do you see that? RT, which is the whole entire thing, is twice as big as this thing right here. It's RT, it's twice as big right there as RZ. And now I can solve for x. So let's do that real quick. I have to do a little distributing. That's 8x plus 2. Subtract a 5x from both sides, I get a 3x. Subtract a 2, I get a 6. Divide by 3, x is 2. It's not my answer because they asked for ZT. But again, remember, I want to find ZT, but ZT and RZ are exactly the same thing. So basically, I'm just going to put a 2 and plug it in for RZ. So 4 times 2, which is x, which I just found, plus 1. That's 8 plus 1, which is 9. And that should be my answer. So now we found RZ, but you understand that ZT and RZ are exactly the same thing. So ZT is equal to 9. Alright, let's do number 12. Now we're going to deal with some angles here. It says angle SRT. Let's find that first of all. SRT, that would be this one right here. That's SRT, is x plus 9. So that's x plus 9. And then UTR, find that UTR, that would be this one right here, is 2x minus 44. 2x minus 44. Find angle UTR. So UTR. So I'm finding this angle right here. Okay. What do you know? You know it's a rectangle, right? If it's a rectangle, it's also a parallelogram, which means the RS and UT are parallel to each other. This is a transversal. So look, this angle right here that was given and this angle right here that was given, they're alternate interior angles. What do we know about alternate interior angles from way back? Well, you know that they're equal to each other when you have parallel lines. So I'm going to set these two angles equal to each other. And then I'm going to solve for x. Subtract an x from both sides. I get x. Add a 44. And I get what? 53? So that's what x is equal to. But that's not what I'm trying to find. I'm trying to find what this angle is right here. Now watch. I could put it into here. I don't want to mess you up too much. But look, I could put it into this. But then I'd have to double 53 and take away 44. I guess that wouldn't be that hard. But look, these two angles are exactly the same if you wanted to. You could just plug it into that, couldn't you? So 53 plus 9, and that would be 62. So that angle and that angle are exactly the same thing, but angle UTR is equal to 62 degrees. If you wanted to, if you don't believe me, you could always take 53, put it here, that'd be what, 106. 106 minus 44 would be 62. All right, you could do it that way if you wanted to. I just like this. I thought that was a little easier. Alright, the last one of these kinds. So let's see, we've got angle RSU. RSU, that would be this angle right here, is x plus 41. And then TUS. TUS, that would be this one right here. This is starting to look like the other problem, isn't it? 3x plus 9. Alright, and then find angle RSU. So we're looking for this angle right here. Yeah, this is identical. Probably should have picked a problem that was a little bit tougher, but it's exactly the same thing, just the numbers a little bit different. These angles are equal to each other, so let's set them equal to each other. Let's solve for x. Subtract an x, give you 2x. Subtract a 9. Subtract a 9, that'll give you a 32. Oops. Okay, divide by 2, it gives you 16. It's not what they asked for though. They asked for this angle right here. So it's just a matter of going 16 plus 41 and that'll give you 57. And that's angle RSU. Angle RSU equals 57 degrees. Alright, this says it's a rectangle again, okay? We're just dealing with a rectangle, so we should be familiar with that. It says find each measure if angle 1 is 37 degrees. So angle 1 is 37 degrees. Now this time we're dealing with the angles, okay, and not just the lengths of the sides. Well, we did both, I guess, on the last set of problems. But we've got 37 degrees, and we really didn't discuss this, but remember, that's a right angle right there since it's a rectangle. So let's find angle 2. Angle 2, this is number 14 and 15. Okay, so we're going to find angle 2 and angle 4. So angle 2, what is it? It's just 90 minus 37. Oops, 7, not 6. Why did I write that? Okay, and that's what? 53 degrees. So that would be angle 2. It's as easy as that. Look, angle 4 is even easier. We did this up in the other problem. We did it twice already. This is angle 1, this is angle 4. Look at them. There are alternate interior angles, so they're exactly the same. I don't have to do any work on that at all. Angle 4 is just 37 degrees. Okay, we've got a rhombus this time. Remember what a rhombus is. A rhombus is a quadrilateral with all four sides equal to each other. And we've got a couple special things. We've got, what do you call those things? Diagonals. Okay, we have diagonals. What's true about the diagonals of a rhombus? Well, a rhombus, remember, is also a parallelogram, so they bisect each other. But what's special about a rhombus? What's special about a rhombus is the diagonals are also, that doesn't kind of look, let's make it look a little bit better. The diagonals are perpendicular, okay, so they all form a right angle right here. Now this particular picture looks like a square, okay, this is not necessarily a square. It doesn't say that these are all right angles right here, so don't just go by what the picture looks like, only go by the information that they give you. So remember, it's a rhombus, which means all four sides are equal to each other, so that's helpful. We know the diagonals bisect each other. Doesn't mean the diagonals are equal, okay, because we don't know it's a square, which means we don't know it's a rectangle, so we cannot say that the diagonals are equal to each other, but we do know that the diagonals bisect each other because it's a parallelogram. Because remember, rhombus is a parallelogram. Let's throw some numbers in and see what we get. It says RK is 5, and let's find RK. That's 5 right there. RY is 13. RY, that's this top one. That's 13. And angle YRZ. YRZ, this angle right there is 67 degrees. I'll try to slide that in there. Okay? And we want to find what the other measurements are. So we want to find what KY is equal to. Let's find KY. KY would be this side right here. We'll put two little tick marks just to indicate which side we're trying to solve for. Or I'll tell you what, since we're not using any other real variables here, we'll say it's X. Alright, so if you look at this, remember this is perpendicular what we said before, so that's perpendicular, which means you have a right triangle right here. See this triangle RYK or RKY, whatever you want to call it? That's a right triangle. The hypotenuse is 13. One of the legs is 5. We're trying to find the other leg. Well, if you have a right triangle and you know two sides of the right triangle, you find the third side by Pythagorean theorem. All right, so let's do Pythagorean theorem. It's a squared plus b squared equals c squared. The a and the b are your two sides, or two legs of the right triangle. That would be the x and the 5. So I go x squared plus 5 squared equals, and then this is 13 squared. And then just go ahead and do your math. That's 25, and that's 169. Subtract a 25 from both sides. So you get x squared equals 144. How do you get rid of this? Take the square root of both sides. To take the square root, we only use the positive version, which is 12. So there you go. X is equal to 12. Now there's another way. We're going to have a chapter later on that just deals with right triangles and nothing else, and we'll talk more about it then. But this is actually one of our special types of triangles. You might have remembered a 3, 4, 5 triangle. This is another one of our special triangles, 5, 12, 13. If you would have recognized a 5, you didn't know this, and 13, you could have just looked at it and said, oh yeah, that's one of those 5, 12, 13 triangles. Again, we'll talk about that when we get to the right triangle chapter, but that would have been a lot easier than having to go through the whole Pythagorean theorem. But this wasn't hard, though. I think you should be able to deal with that. Alright, let's solve for angle YZR. Let's find that. YZR would be this one right here. Well, if you take a look at it, again, this is one of those where you don't even have to do any math. If you look at this triangle right here, RYZ, everybody see that one? RYZ, this triangle right here. I've got two sides that are equal to each other. I've got this and this are equal to each other. If I have two sides of a triangle that are equal, that means the opposite angles are equal as well. So look, I already knew this was 67. They told me up here that it was 67 degrees. So guess what? This is opposite 13 as well, right? Opposite equal sides, so this has to be 67 degrees as well. So number 17, angle YZR is 67 degrees without doing any math at all. It's just recognizing that when you have a triangle with two equal sides, the opposite angles are equal. That's all there is to that. Alright, here's the last little section of this, and it's 18, 19, and 20. So this is a trapezoid. Now we're not doing parallelograms anymore, it's a trapezoid. Remember, on a trapezoid, exactly one pair of opposite sides are equal to each other, and that would be HJ and LK, right? Indicated by those arrows. So it says T and S are midpoints, so that's going to be helpful. So that and that are equal, and this one are equal to each other. And let's see what they ask for. It says if HJ is 14, that's 14. And LK is 42, that's 42. Solve for TS. This is pretty straightforward. We'll call TS X. Well, if you remember, on a trapezoid, these are the two bases. These two bases, the sum of the bases, if I take half the sum of the bases, that's equal to this, which they call the midsegment. Right? So if I add these two up, add the top and the bottom together, take half of it, that's what the length of TS is. It's kind of like the average, if you want to think of it. This middle one right here, the midsegment, is the average of the two bases. So you just add them up, right? You get 56, and then take half of it, so however you want to show that, divided by 2, and that's 28, and that's what TS is right there. X is 28, or TS if you want to call it that. TS is 28. Alright, number 19, it says HJ is 7, alright, so it kind of tells you the same thing. TS, this time they tell you the middle part right here, and then find LK, and we'll call that X. It's the same idea, it really is, except you just don't know the base and you know the midsegment. But you're going to set it up exactly the same way. We're going to add the top and the bottom together, so we're going to go X plus 7. Now remember what we do. We add the top and the bottom, or the two bases, together. We divide it by 2, and that should equal the midsegment. And we know the value of the midsegment this time, and it's 10. So if you just set up this little simple algebra problem, you should be able to solve for X. Multiply both sides by 2, so that would give you 20, and then subtract 7 from both sides, so X is 13. And there it is. So LK is equal to 13. If you wanted to see if it worked, put it in here. That's 13. Remember, if you add the top and the bottom, divide by 2, you should get this. 13 plus 7 is 20, divided by 2 is 10. Okay, this is the last one of the whole review. So we're finally here, and this is so easy. Watch. If JK is equal to 10, so I'm going to mark it like this. So that whole thing right there is 10. Remember, this is a midpoint, J at point S right here. So this side and this side are equal to each other. Find SK. There you go. You got the whole thing. If this is the midpoint, splits the whole thing in half or into two equal parts. So SK is just half of 10, which is 5. So SK is 5. All right, that's it. Hope you enjoy the midterm. Anyway, we'll see you when it's time to take the midterm, and hope you do well.